Hello everyone, I am Minakshi working as an assistant professor, IT department, KIET group of institution, Ghaziabad. In this lecture, I will be discussing about programming techniques. So let's get started. A program is a set of instructions and we write program to implement some logic. A program is an implementation of certain logic. To implement this logic, we need some programming techniques. These programming techniques can be looping, counting, and indexing. We write a set of instructions to perform the particular task. We need some programming techniques. These techniques can include looping, counting, indexing, as well as code conversion. So, what is looping? Looping term indicates that we are going to perform a task repeatedly. We execute a set of instructions repeatedly to perform a particular task a number of times. For example, if we want to add 10 numbers stored in a consecutive memory, so we have to perform addition 10 times. We will require a looping technique to implement the addition of 10 numbers. What is counting? Whenever we perform some looping, it repeats a task. But how many times this task will be repeated? Counting technique helps to count how many times the instruction set or instruction will be executed. Indexing. This technique allows programmer to point or refer the data stored in sequential memory locations one by one. So indexing technique helps us to point or refer the data stored in sequential memory locations. For example, if we want to add 10 bytes of data stored in the memory starting at any given location. So for addition of 10 bytes, what procedure will be followed? Here we want to add 10 bytes of the data. A counter to count 10 will be required. We must have some index, an index or a memory pointer to locate the data bytes. Then data bytes will be transferred to the microprocessor so that addition can be performed. And addition will be performed by the ALU. Here, when the data will be transferred to the microprocessor, we will require some registers to hold that data. So registers for temporary storage. And when we will calculate the addition, then some register will be required to hold the partial result. A flag will be required to indicate the completion of task. It will indicate that we have performed the addition of 10 elements. And finally, a register should be required to hold the result. So in this way, if we are going to add 10 bytes of the data, we will require a looping, counting, we will require an indexing. Looping technique. A looping technique is used to repeat the sequence of instructions as we have discussed already. And we have two types of loops. One is continuous, second is conditional. So continuous is a kind of unconditional loop. They will repeat the task continuously without checking any condition. But conditional loop repeats a task until certain data conditions are met. So conditional loop will require a condition. The condition will be tested. If it is found to be true, then the conditional loop will work. So continuous loop, how we can implement the continuous loop. So as you can see in this picture, we will start, we will perform some task. Whatever task is being implemented, we will perform this task. and go back and repeat the process. In continuous loop, no condition will be checked, and this continuous loop will be implemented by jump instruction, which is unconditional jump. Conditional loop. To implement conditional loop, first condition will be tested. If the condition is found to be true, then loop will work. Otherwise, it will exit from the loop. So conditional loop will be implemented by conditional jump instructions. And for conditions, various flags will be tested. Flag like zero flag, sign flag, parity flag, carry flag, etc. And repeat the specific task if condition is met. Any loop can have four sections: initialization section, processing section, loop control section, and result section. For a condition loop, the condition can be checked at the entry of the loop or at the exit of the loop. In this flowchart 1, we have starting of the loop, then initialization section where various variable will be initialized. Then we will have processing. So this loop will at least perform the task once, because first it is performing the task. It has processing section. And then it will have loop control section. Here it will update the loop control variable. Once the loop control variable has been updated, it will check the condition, whether the loop will continue or exit. If the condition is met, it will go to repeat the task. Otherwise, it will exit from the loop and will go to the result section. In the second flowchart, we have start section. Then we have initialization. Here we have control section. First, the condition will be checked. So condition at the entry point will be checked. If condition is found true, then it will do the processing or the defined task, and again it will go to the loop section. Next, we'll update the loop control variable, check the condition. If condition found to be true, then it will again repeat. If condition found false, then it will go to the result section. So here in this we have the condition at exit point, here condition at entry point. So it is the example of do while loop you have done in C programming language. It executes a set of instructions at least once before checking the condition. And you have for loop in C language. In for loop, it first checks the condition. If condition is found true, then it will go inside the loop. Otherwise, it will exit from the loop. So in this way, conditional loops can be implemented. Condition can be checked at entry point of the loop or at exit point of the loop. Along with these techniques, looping, counting, and indexing, we use code conversion programming techniques too. Sometimes we require that a number represented using one code may be converted into the other code. For example, we are entering the keys from the keyboard. These key represented in ASCII code, and the computer processes the data in binary. So the ASCII code must be converted into the binary. So code conversion involves some basic conversions such as BCD to binary conversion, binary to BCD conversion, BCD to 7-segment code conversion, binary to ASCII code conversion, and ASCII to binary code conversion. First, we will discuss BCD to binary conversion. The number is represented in BCD code, and here we will require to convert the BCD number into binary. For this conversion, we will use a positional weighting method. To perform our operation, it is necessary to separate 8-bit packed BCD number into two 4-bit unpacked BCD digits. First, BCD1, BCD2. So whenever a number is given into BCD, direct binary coded decimal, then the number is called packed number. And we have to separate these numbers into two 4-bit unpacked BCDs. Once we have got 4-bit unpacked BCD digits, then we will convert each digit into its binary value according to its position. So we have to remember its position. In decimal, the base is 10. So first position in 10 to the power 0, second position in 10 to the power 1, next position in 10 to the power 2. In this way, we will use the position of the digit. Finally, we will add both the binary numbers to obtain the binary equivalent of BCD number. Here, for example, if we have 72 BCD, now we will convert 72 BCD number into its binary equivalent. So we have 72. We will write the BCD. For BCD code, we will write the 4-bit binary for 2 and 4-bit binary of 7. We have BCD of 7 here and BCD of 2. And now this packed BCD number will be converted into two unpacked BCDs. So first BCD1 unpacked number will be 2 and second unpacked BCD2 will be 7. Here 7 has weight 10. So we will multiply 7 by 10. Because its position is 1, its position 10. Now we will multiply the BCD to 7 by 10. And this multiplication can be performed by any algorithm we study in computer organization. Now we will add BCD1 to the answer in the step 2. Now we will add BCD1 into the product from step 2. In this way, the final number will be binary equivalent to the 72. By following this algorithm, we can compute the conversion of BCD code to the binary. Here, binary to BCD conversion. We know that processor processes data in binary form. But when it is displayed, it is in BCD form. In this case, we need binary to BCD conversion. The conversion of binary to BCD is performed by dividing the number by power of 10. And we know the division is performed by the subtraction. To convert a binary number to the BCD, we will divide the number by power of 10 and the division will be performed by subtraction. In this example, we have this binary number. And this binary number is equivalent to FF in hexadecimal and 255 in BCD code. Now we will see how this binary number will be converted into this BCD code. So to perform this conversion, in first step, we will check whether the number is less than 100. If number is less than 100, we will go to step 2. If given number is greater than 100, so we will subtract 100 from the number. And subtraction will be done until the remainder is less than 100. We will check whether the number is greater than 100 and we will subtract 100. Then if number remainder is greater than 100, then we will subtract again 100. And this process will be done until the remainder is less than 100. The quotient is the most significant BCD digit. And this digit will be BCD 3. So here we will write the quotient. And quotient is the number of subtractions we performed. If now the number is less than 100, we will perform step 2. In step 2, we will check whether the number is less than 10 or greater than 10. If number is less than 10, we will go to step 3. If the number is greater than 10, we will subtract 10. And we will repeatedly subtract 10 until remainder is less than 10. And now the number of subtraction will be termed as BCD2. So this will be BCD2, which denotes the number of subtractions by 10. Once the number is less than 10, the remainder will be termed as BCD1, and this will be the digit. BCD to 7 segment conversion. This code conversion will be required only when the BCD number is displayed by the 7 segment LED. And to implement this conversion, we require hardware consideration. The hardware implementation will be done to implement this BCD to 7 segment conversion. And this hardware consideration can be common cathode or common anode LED. This code has no direct relationship to the binary numbers. To display a BCD digit, a 7-segment LED, the table lookup technique is used. In table, we have codes of digits. So in VCD, we have 10 digits 0 to 9. And in lookup table, we have 10 corresponding codes for 0 to 9 digits. And these codes are stored sequentially in the memory. The conversion program will pick the code for a digit, whatever digit will be asked. It will locate the code of a digit based on its magnitude or BCD digit. Whatever BCD digit will be displayed by the 7-segment LED, the corresponding code will be looked up into the table. Here, binary to ASCII code conversion. ASCII code, American Standard Code for Information Interchange. It is commonly used for communication. ASCII code is 7-bit code, and this code numbers 0 to 9 are represented as 30 through 39 in hexadecimal. So 0's corresponding code 30H and 9's corresponding code 39H. And the letter A through Z are represented as 41H in hexadecimal and Z 5AH in hexadecimal. So to convert a number into its equivalent ASCII code, we will add 30 to 0 and to 9. So we will get the corresponding ASCII code. And for letter A and Z, we will add 37 to convert its equivalent ASCII code. So for less than A, we will add 30, and greater than A, we will add 37 to get the ASCII equivalent code. It is important to note that 30 and 37 is also in hexadecimal notation. So when we will add, we are in hexadecimal notation. So in this lecture, we discussed about programming techniques. And these techniques are looping, counting, indexing, or code conversion. Thank you. Happy learning.